Okay, so for this experiment, we're going to be testing the effects of osmosis by using gummy bears to see whether or not they shrink or expand depending on the solute that they are submerged in. So I have the materials here. I have three different colored gummy bears just to keep track. Um, Two different cups for the test solutions. I'm going to be using this regular iodized salt as the solute, and then a ruler to measure the results. You also need access to a refrigerator and tap water. First step in the experiment is going to be measuring each of the gummy bears, so that way when the experiment is over we can compare the initial sizes to whether or not they grew or shrank during the testing phase. So the gummy bears here and the ruler. We're going to be using metrics, so we're going to be doing centimeters. I'm going to measure the red gummy bear. You want the height, the width, and the depth. And then we're going to multiply to get the volume. Okay, so we got all the gummy bears measured, and I recorded the results on this index card here that I'm going to enter into the computer document. Um, but I went ahead and got the total volume of each gummy bear measured in millimeters cubed. It's important just for accuracy's sake and consistency. Okay, so for posterity's sake, I have the layout right here. So you can see this is going to be the initial 0-hour size, the control in the two treatments. So we're going to see what happens over the course of the next 72 hours. We're going to remeasure and document the results. So for this experiment, I hypothesize that, of course, the control gummy bear is going to remain the same as it is not being subjected to any treatment. The gummy bear in treatment 1, which is going to be the tap water, I hypothesize that the tap water will cause the gummy bear to expand due to the higher concentration of solute inside the gummy bear compared to the surrounding environment. And I hypothesize that the red gummy bear in treatment 2 with the salt water will shrink because of the higher concentration of solute in the water surrounding the gummy bear will draw out the water inside the gummy bear through osmosis. Okay, now that we've taken our initial observations about the size and condition of the gummy bears, I'm going to go ahead and get ready to subject them to the test. So over here I have the blue gummy bear. It's in an airtight sandwich bag, doing that to keep the dehumidifying effect of the refrigerator from drying out the gummy bear, because that could also make it shrink. We don't want that. So that's airtight. I have the H2O, which is the treatment number 1, and the green gummy bear ready to go. And I have the treatment number 2, which is the salt water, and the red gummy bear right here. I still need to cool this down a little bit. I boiled the water 1 1/4 cup and slowly added in a 1/4 cup of salt. It's very concentrated solute. Still trying to get all the salt to dissolve in here. Once this cools down and everything's ready to go, I'm going to submerge the gummy bears into the test solutions, and then tomorrow at about this time I'm going to make my first set of observations about what kind of osmosis effects are taking place on the gummy bears. Okay, so it's been a little over 24 hours since I began the experiment. I just removed the gummies from the refrigerator and from the solutions, dried them off. I'm going to go ahead and measure them now, and I'm going to compare them to the initial measurements and see if my hypotheses were supported or rejected. Okay, so the results are in. and 2 out of my 3 hypotheses were supported, and 1 was rejected. The one that was rejected was the gummy bear in the saltwater solution. Um, we can infer that there was not enough salt in the water and that the solution ended up being perhaps isotonic rather than hypertonic. So yeah, the gummy bear stayed exactly the same. The control stayed exactly the same, which is supported by hypotheses. And the treatment number 1 in the tap water, that hypothesis was also supported. Um, the gummy bear grew in size over double the volume. Okay, so for the next part of the experiment, we're going to be switching the treatments. So the gummy bear that was in the tap water is going to be submerged in the salt water for at least 24 hours, and the gummy bear that was submerged in the salt water is going to be submerged in the tap water for at least 24 hours. Then I'm going to make some new hypotheses, which will be in the document, and after the 24-hour period has elapsed, we will take the gummy bears out and see if our hypotheses were supported or rejected. Okay, so it's been another 24 hours. I've just concluded the final phase of the experiment where I switched the gummy bears in these solutions. So the gummy bear that was initially in the saltwater solute was submerged in H2O, and the gummy bear that was submerged in H2O was switched over to the salt water. So I'm going to go ahead and measure them right now so we can objectively compare them to the initial stage and the second stage. Okay, so the results are in, the measurements have been recorded, and all of the hypotheses were supported. The green gummy bear that was initially subjected to the H2O and swelled up to twice its original size has essentially returned back to its original size. The red gummy bear that was initially subjected to the saltwater solution, it initially did not shrink at all. It pretty much stayed the same size. However, when it was subjected to the H2O, it did swell up. And the control remained consistent throughout the entire experiment. So we can take a look here. And the expansion and contraction of the gummy bears has caused some considerable damage. The red gummy bear is basically split in half, but I held it together as well as I can to get the most accurate measurements. The green gummy bear is kind of falling apart too. The control is perfect though.